All right, so we're going to talk about the parts of the atom. Protons have a positive charge, and they are found in the nucleus. Electrons have no charge or neutral, so zero charge, and they are also found in the nucleus. While electrons have a negative charge, and they are found outside the nucleus in what's called the electron shell or the electron clouds. Okay. Together, the protons and the neutrons make up the mass number. Okay. The atomic number is the same as the number of protons. This is the identity of the element. If you change the number of protons, you're changing what the element is. It's like the element's social security number, right? So the number of protons that an element has is unique to that element, right? When you have varying numbers of neutrons, so different numbers of neutrons, that is called an isotope. So two atoms that have the same number of protons but different numbers of neutrons is called an isotope. For right now, we will assume that elements have the same number of protons as they do electrons. Eventually, we're going to get to the point where we have different numbers of electrons, and that's an element or an atom that has a charge, which is called an ion, but we're not quite there yet. So we're going to learn how to write something called standard nuclear notation. And this represents the element that we're talking about along with the number of protons and the number of neutrons. So the general form is we use the element symbol, which we're just going to put as X right now. So this is the element's symbol. And around the symbol can go different numbers. Eventually, we're going to learn what goes into all four corners, but we're only going to deal with the left two right now. Okay, so let's show what that looks like. So in the top left corner, let me get that erased, there you go. In the top left corner is the mass number, and it gets the letter A for no specific reason, but that's the mass number, which remember the mass number is the protons plus the neutrons. And in the bottom left corner is the letter Z, which is the symbol for the atomic number. And remember, the atomic number is the number of protons. So if we were to do an example, if we wanted to write the standard nuclear notation of, say, fluorine 19, this notation is the element's name dash the mass number. So the symbol for fluorine is just F. The mass number is the number in this written out notation. So 19 goes in the top left corner. And then on the periodic table, fluorine has an atomic number of 9. So that goes in the bottom left. So this element of fluorine has 9 protons, 9 electrons, because remember right now everything's neutral, and then 10 neutrons. To figure out the number of neutrons, you do the mass number, which in this case is 19, and you subtract the atomic number, which in this case is 9. So if we were to look at another example, what about oxygen 18? Well, the symbol is O. The mass number is the number that's in the notation, so 18. And on the periodic table, oxygen has an atomic number of 8. So the number of protons is 8, because that's the atomic number. The number of electrons is also 8 because this is going to be neutral. And the number of neutrons is 18 minus 8, which is 10.